I will be discussing how to take your telecom closet outdoors. So small introduction of myself. I am an electrical engineer, graduated from Drexel University. Been in the business now for about 30 years, working with Ventev for about 10 years, doing conceptual designs of power systems, not just grid tie based, but also stuff that is intermittent power and solar enclosure systems. I'm also the lead engineer in the design-in program for Cisco that we just started this spring with them. So what's our play with the power? Why come to Ventev with power? Well, basically, we go through and we listen to the customer. We don't say, okay, you can buy this box and customize it yourself. If a customer comes to us and says, hey, we have an opportunity, but your standard product line doesn't quite fit what we need, we will sit down and work with the customer to come up with a solution that will go through and solve their problem, simplify the deployment, because let's face it, going out in the field, you want to have boots on the ground the smallest amount of time because it just is expensive, and also reduces operational costs. We can also go through and do kitting and staging of the solutions. So if you have a requirement where you want to drop ship to certain sites and you want to have all the hardware, not just the enclosure, but you want to have the brackets and the cabling and all that, we can put together a BOM for you that we can go through and you can order one SKU number and everything is delivered at that site. Okay, just at a quick glance, these are some of the solutions that we have. We have solutions that are PoE powered, so you just have PoE coming from your telecom closet and you just plug and play with your access point in the enclosure. We have them with integrated antenna as shown here. We also have them with patch antennas as well. We have various UPS systems to support network down. Again, this is a plug and play situation where you have an IoT application where you need to plug in sensors and have PoE and want some backup that you can go through and you can hang this box and have that. You have the power extender, which if you don't have power 24/7 out at your facility, this is one of our solutions, specifically for light poles that don't have power all the time. And then we also have solar enclosure systems as well, so where just it is too expensive to go through and trench power. At this point, the cost for trenching power is about $15,000 for every 100 feet that you go through and trench. So if you're talking, we've had situations where we've talked miles that a customer needs a deployment, it's just not worth them going through and paying for that. So taking the telecom closet outside. Okay, what's that mean? Well, your standard telecom closet is indoor. Your traditional, it's your central hub for your network. You usually have one central location. It's expandable. It's accessible with no problems. You can get power easily to it. You can run PoE injectors if you just run out of the 300 foot. And the building's also backed, usually if the customer is concerned about having the network when power goes down, usually the building is backed up either by generator or battery or some sort of auxiliary power plant. Now, taking that telecom closet outdoors. Well, now we're talking smart cities, smart grids, mobile commerces. We're talking about asset tracking, things that people are trying to do external to make, to improve the quality of life. Smart grids. almost everybody, all the utility companies are using smart meters. There's no more meter readers. That stuff is being ported back to a local hub, which is then sending the data back into the customer database. Okay, smart cities with traffic control, cameras for security, biometric devices to allow people access to things. All of that is now starting to use IoT. All of that's going to need power. And where you're typically putting these things, power is not a convenient thing. You're no longer close enough to run your cable out from your telecom closet. Okay, UPS, there's a lot of customers now that are asking, hey, I have a security camera, power goes down, I want the ability for that camera to stay up and operational. Okay, and everything has to be self-contained because there's, if you go out and everybody's seen it, you go out to small cell deployments and you've got boxes upon boxes that are tied to a utility pole. And it becomes an eyesore. So a lot of people are interested in aesthetics. They want it all self-contained in one box. Okay, so let's go through some of the design factors. And I apologize, I'll have to go through this rather quickly. So the design factors that we need are load, backup time, where you're going to deploy it, and what power is available. Now, when we go through, Ventev has a customer that comes for a design. What are we looking for? First thing is we need to know about the load. We need to know about the load voltage, current, and continual or duty cycle. Now, what these two charts are showing you is what happens when you go through and you operate something continuously as opposed to going through and operating something, over a short period of time. So I took a biomed sensor, running it 24 hours a day, biomode sensor at a door. You have about 12 amps a day that you're going to be drawing from that sensor. Okay. Now, if you take the same sensor and go, well, I've got a camera tied to it. If I go through and when I see somebody on camera, then I'm going to activate the biosensor. You can go through and decrease the time. So now maybe instead of 24 hours a day, you're only really going to operate it an hour a day, letting people in and out at various times. And the rest of the time, it's going to be in a standby or sleep mode. Okay. Notice you're almost 10 amps lower in the amount of current that you need per day to go through for your battery bank. So that's very important when you go to size things. Maybe not so much for UPS, but it is definitely a game changer for solar enclosure systems. And then you also have to take a look at transmit versus receive versus standby. And what the table down below shows you is if you go through and take a look at the same radio at the different modes, you can see how many amps per day that radio draws. So obviously you don't want your radio transmitting 24/7 because that's going to be 7.2 amps a day. What you really would like to know is how much am I actually going to be transmitting and how much time is it going to be receiving, and in a sleep mode to try to minimize the amount of current capacity that you're going to be using. Okay, backup time. Okay, what are you trying to do? Or is it just you're notifying that you're losing power? You want to do one final backup or one final message or dump data one last time before you lose the power? Do you want power until a technician arrives? Do you want continual power to go through? And how long does that system have to operate if you want the last two bullet items on that list? Okay, where you're going to deploy it. Is it going to be an outdoor deployment in building? What's the environment like? Then you also have to worry about, is it going in a harsh environment? Do you have to worry about salt spray? We had one customer that went through and had an LTE deployment, and he said, yeah, the box works great, but we're having problem with corrosion. Well, we asked about, well, where are you putting the box? And it's like, oh, well, this box is going out on a pier. And it's like, wait a minute, you never told us that you were going to put this in a salt environment. Okay, that makes a difference. It's a big play because you have to go through and gear the enclosure that's going to hold the equipment accordingly. Okay, now what we do is in the deployment environment, we take in consideration the solar loading of the enclosure. So in this table here is the thermal analysis that I go through on a product when I go and take a look at a customer's need. In the red square, what you have is you have the thermal calculations based on the solar loading for the enclosure. How much heat's inside being generated, what's the contributions for the solar loading on that particular box. And then below, the next two boxes below, the first one is, okay, if I set the maximum temperature, which if you notice in the lower right is 40 degrees C, this is what it would be at the maximum temperature, whereas the minimum temperature, which is minus 20, this is what the inside of the box is going to be. Now, along with that, we do temperature compensation with our battery backup. A lot of our competition goes through and just says, oh, here's your battery backup, but it's at 25 degrees C. Where we differentiate is we actually go through and take a look at the thermal curves for the batteries, and then go through and look at the deployment and actually compensate for the battery. So that way, if you can see, you have your 1 amp load, and you can see at 25 degrees C, I have 11.3 hours of backup, whereas minus 20, I have almost a little bit more than half of that. So there is a big difference in play when we're talking about our thermal loading and compensation for the batteries. Okay, just real quickly, our power availability, you have our 24/7 power, which is just your typical UPS. You have your intermittent power, which is our power extender, and then no power, which is the solar enclosure system. Okay, now what I'm going to do is real quickly, I'm going to go through one of our recent products, which is a Cisco design for the design-in program for an IE 3200 switch with UPS. This specific design was made for 24/7 power, so it's strictly a UPS design. What you see here is the anatomy of the box. So you have a battery charger power supply. This is operating at 48 volts. You have your switch, you have your terminal blocks, thermostat with a fan, and your battery backup. You also notice that there is plenty of DIN rail space that you can snap other sensors in. Now on the far right, you can see a bunch of bulkhead connectors there. What that actually is 8 RJ45 bulkhead connectors that are weather resistant, IP67, that the customer can go through, plug in, and lock their devices. So once you hang the box, you don't need to enter it to go through and make your connectivity. All you have to do is unlock the cap from the RJ45 bulkhead, plug it in, lock the device in, and you're powered up. Okay, now what you see here is what I did for loading. Okay, as you can see in the lower right, you have your ports. Okay, and what I did was on this particular one, I went through and took the PoE plus, which is 35 watts out per port. And as you can see, you have the various power levels for the number of ports. So how do you go through and size this? Well, for this particular device, seeing it's a standard product, we went through and I sized the maximum. So you took your 35 watts of power consumption, which is your overhead for the switch, and then you added all 8 ports worth of power, which is how you came up with the 275 watts of power in the table on the left. Okay, and then we went and sized from there. Now, based on this, if a customer naturally is only using 3 or 4 ports, you're going to get more battery backup time on this, and the box is going to be a little bit more efficient because you're using less power. Okay, now what this slide is showing you is the differences in the configuration. So again, this is a switch versus PoE versus PoE plus, which is similar to the standby transmit receive from the loading on the radios. So standard switch, if I use the 3200 as just a switch, I'm just using 35 watts worth of power. Then you can see the various power differences depending on what the customer is using. Again, for the standard product, I use the PoE plus and 8 ports. But customers using different ports, using PoE, not PoE plus, they're going to get longer backup times with this enclosure system. Okay, again, this one was specifically for, I want a notification that power is going to be lost and I need to do one last send of data. And my backup time was 0.5 hours. Okay, this is just where it was going to be deployed, seeing it's a standard. It could be indoor, outdoor, no harsh environments. Okay, the thermal analysis. What I want to show here is in the center square, the solar loading and the heating, I had 40 degrees C increase. And as you can see on the right, I've got red on my maximum. So on my maximum temperature range. So that's no good. So how do we go through and mitigate it? Well, what I did was I ended up putting a fan in. So we actually went from a NEMA 4X box to a 3R box, okay? And putting a fan in, I mitigated all that temperature so it can be deployed regionally in the continental United States. As you can notice, I still have, in that center square, I still have the loading of 40 degrees C. Where I'm going and where I'm dissipating that heat is with the 76 CFM fan to cool things down when it gets too hot. Okay, and the temperature loading for the battery, we took a look at that as well. And this is just a showing of the calculations, the load profile, and going through and making sure that we could hit the target of 0.5. Now, as you see on the table, it says 0.4. We were actually at 0.48 on this particular one. And taking a look at the tolerances, the customer said, well, the Cisco people, when they looked at the design, said that's within the tolerance spec. We're comfortable with that, so release it for the 0.5 hours.
Hey, Jim, is this calculation, the spreadsheet stuff, is this something that Ventev does as a service, or is this a web page that we can go to and fill out on our own, or how do we get this sizing information specific to our environment?
This is specifically done by Ventev. This is not out on the web. There's a lot of proprietary calculations in there because we've used some of the white papers from other enclosure manufacturers, but we've also done some lessons learned on our part and have done some third-party testing of enclosure systems to prove out some of these calculations. So that's why it's not exposed to the web. So if you need something for the environment, you can reach out to me and I can go through and start some calculations for you. So what you have here is our intermittent. The intermittent power is specifically designed for light poles that don't have power. There's either a light sensor on a building elsewhere or a timer in a building, because building management companies are tired of people pirating power from their light poles. So this was a way to go through, and basically what you're doing is you're operating on battery for 18 hours, and then you're charging the battery and operating on AC for the other 6 hours when the batteries are being charged. So
I got a question real quick
sure.
right here, with this particular picture, actually, because I've recently been presented with a similar situation, which some of the delegates and I have been talking about in the background. How do you not void manufacturers' warranties on poles like this due to wind loading?
So that's one of the design questions that we ask. Specifically, as you can see with the enclosure, we recommend that it be lowered down. If the customer does have a question or comment, one of our design form things that we ask is there wind loading requirements on it? And they fill out the design reform with them. We have the capability to go to a third party to go through and do wind loading for the load, but there would probably be an NRE charge as a result of that, because that's something up and above that what we normally do. Okay, so this is just showing, the one thing I would say is that combined power supply and battery charger is a proprietary device that Ventev has designed. And that's what gives you DC power 24/7, whether you're operating on battery or if you have AC coming into the box. And there's a solid state relay in there to go through and toggle back and forth so you're seamless. And then the last thing is just solar. We do solars where there's a design form for that as well. This is showing something that we did out in California, the Han Estates winery, where we were doing a solar pilot for IoT sensors for agriculture. That bomb site, again, refers to everything that we deliver to the customer. So what you see in that picture is everything that Ventev supplied to them on site. So it's not just the enclosure design. We can do a full kit blowout. That is the base on the solar. And then the last thing that I have is just the solar radiation patterns. We take that in consideration when we're sizing the arrays and sizing. So as you can see on the left, the red is your most kilowatt per meters per day that you have. It's not uniform across the country. A lot of people say, well, and the big thing is, well, everybody's putting solar panels on the house. Why can't I just put it, and how come it's got to be so high? This map is the explanation because of the way the sun hits the earth and how the energy is distributed. And with that, that is the end.